So when last we met, we've been talking about right triangle trig and finding missing parts of a right triangle. So for right now, I'm going to have you look at this triangle where I give you a right triangle, a right angle, and I tell you that this side over here is 18 feet and that this angle is 32 degrees. Can you find the other sides? Go ahead and take a couple minutes in your notes and find the other sides. So, first thing we can find is this angle right here. What's it going to be? 58 degrees. We're just subtracting 90 minus the 32. Now to find the other two sides, I'm just going to label this side A and this side C here. I'm going to keep using my 32 degree angle that was given. The 18-foot side, which was also given, is what side compared to the 32 degrees? It is the opposite side. Of course, C would be the hypotenuse, and A then would be adjacent side. So if I'm trying to find side A, I have opposite and adjacent, which is tangent. Tangent of an angle equals opposite over adjacent. So I'm going to fill in what I know. I know the angle is 32 degrees. The opposite side is 18, and I am looking for that adjacent side. So I put this over 1, I cross multiply and divide. So I get 1 times 18 is 18 divided by the tangent of 32 degrees. So you get 28.81. How many of you had 28.81 feet? Just one? Just 1 times 18 is 18 divided by the tangent of 32. Oops. 18. 28.81 it should be. So then to find C, I could do a squared plus b squared equals c squared. I'm going to go back to my trig functions though because I can. So I have this, I have the opposite side, and C is the hypotenuse. Opposite and hypotenuse make the sine of an angle. So I will fill in what I know. Sine of 32 degrees equals 18 over my hypotenuse. Put this over 1, I will cross multiply and divide. So 1 times 18 is just 18 divided by the sine of 32 degrees. $33.97. How many of you had 33.97 for the hypotenuse? Good deal. Okay, so today we're going to be looking at some applications of these. The tough part when we start dealing with applications is often just picking out where the triangle is. So we'll start out with some easier ones, and then we'll move up from there. So our first example is going to be finding the distance across a river. You have two posts, and basically what you want to find is the distance between the two posts rather than just across the river, because you want to string a rope between the two posts. To find that distance, what you can do is this. Remember we talked about that theodolist or theodolite? Theodolist, remember we were doing the job site layout, finding the corners of the house from your reference point? So here's what we're going to do, is we're going to sight this line of sight. Then we're going to come over here this direction at a right angle. And let's say we're going over here 20 feet. Then from this point, we're going to sight back to that post on the other side, and we find that this angle here is 71 degrees. So in your notes, find for me the distance across the river. So, what'd you find? Okay, so this is the opposite side and this is the adjacent side, so we are working with a tangent, right? So filling in what we know, it's the tangent of 71 degrees equals that opposite side over 20. Put this over 1, we can cross multiply and divide. So tangent of 71 times 20 divided by 1 is 58.08. As long as it works. So 58.08 feet. Anybody get something different? Okay, good, because you would have done it wrong. So let's say that we are going to work on a house, but this house is on a hill. And this city has an ordinance that, and this is actually, I've seen cities that have this, that no house can be higher than the peak of the Capitol, or higher than the peak of a certain building. So since this house is going to be on a hill, we've got to deal with that constraint. So we're looking at the house, or we're looking at mocking up the house, how high the house is going to be. And we put just a post, a temporary post up to where the peak of that house would be at. And we have a street down here that we know the elevation of this street. We set up a theodolist. And we sight to the top of that temporary post. The top of the theodolist was set up at 6 feet high. That's the pivot. It finds an angle of elevation of 43 degrees. And it used something called stadia theory. You'll talk about that a little bit more when you do your site survey class next year in the spring. And it gives you an approximate distance from the theodolist to the top of that post of being 172 feet. So what is the elevation of the top of that post, or the proposed elevation of the top of the house from the road? How far is it above the road? See if you can figure that out quickly. Okay, so first thing we're going to find here, we're going to actually look at this triangle and find that distance. We have the hypotenuse, and we're looking for the opposite sides. That's going to be the sine. So the sine over 43 degrees equals, we'll call that height x for now, over a hypotenuse of 172. So if we put this over 1, we can cross multiply and divide. It's the sine of 43 times 172 feet divided by 1, which of course doesn't do anything. So we get 117.30 feet. And of course, that's not our answer. We need to add the 6 feet. 123.3 feet. How many of you had 123.3? Forgot to add the 6? That's not so bad. Well, all of those, finding the triangles was relatively simple, but it can be more difficult. Let's say you are making legs for a coffee table. These coffee table legs are 14 inches high. The bottom has a 1 1/4 inch diameter. The top has a 2 3/4 inch diameter. Here's what I want to find is If I draw this line in here, what's this angle right there? Well, for this one, I can actually finish my right triangle by doing this, just cutting this off at the bottom. Do I know that distance?
Yeah.
Okay, what is it?
It's top minus bottom divided by 2.
Oh yeah, it's half of the difference between the diameters. 2 1/3 minus 1 1/4, which is 1 1/2, and divided by 2 is 3/4. So that is 3/4 of an inch there. Do I know this dimension? It's the 14. Good. So what I have here, according to this angle, this is the opposite leg and this is the adjacent leg, which means I am dealing with a tangent. In this case, I am looking for an angle. So I put in my numbers of 3/4 over 14. To solve it, I'm not going to cross multiply and divide. I am going to do an inverse tangent. So second tangent of 0.75 divided by 14. 3.07 degrees. That angle is 3.07 degrees. Make sense? Any questions?
Could you go over there?
Okay. Do you see where the 3/4 comes from?
Yeah, that
Difference in diameters, and the 14, of course.
Yeah, that's in the tree.
So now we've got, according to this angle, this is the adjacent leg because it's next to it, and this is the opposite leg.
Yep.
So that's tangent of an angle is opposite over adjacent. So we fill in our numbers. We got 3/4 is the opposite. I'm changing it to 0.75 to make it easier on myself. The adjacent is 14. So tangent of the angle equals 0.75 over 14. Now, since I'm looking for an angle, it's inverse trig function, inverse tangent. So do second tangent, then 0.75 divided by 14. And close your parentheses. It equals. Oh, there's another one for you guys to try. Pretend that looks like a circle. Okay, the circle, the big circle is a diameter of 8 inches. I want you to find the distance. It has 6 holes drilled around it. Distance from center to center of those 2 holes. I'll give you a minute to think about that. See if you can come up with it. And then so, let's take a look. From the center of the circle, I'm going to draw this triangle. Can I find that angle right there?
Yeah.
Yeah, how am I going to find it? Yeah, 360 degrees, which is all the way around, divided by 6. Because if I drew it out to every circle, there would be 6 of those. So that angle is 60 degrees. The problem is that doesn't give me a right triangle anywhere. But I can do this. I know that if I draw a line from the center of the circle out to a chord, if I draw it at a right angle, it cuts the chord in half. It also cuts this angle in half. So this is now 30 degrees. So what I have, this triangle here, I'm going to redraw out here. This is a right angle. This angle is 30 degrees. Do I know any of the sides of the triangle? I know that's 4 inches. How? Yeah, it's a radius of the circle, half the diameter. So I'm looking for this side, or that's going to lead to what I'm looking for. That's the opposite side, and I have the hypotenuse, which is sine. So sine of 30 degrees equals that opposite side over my hypotenuse of 4. put this over 1. I'm going to cross multiply and divide. So it's just going to be sine of 30 times 4. Don't have to worry about the dividing by 1. That gives me that the opposite side is 2. Well, this is 2, so the distance between holes is 4 inches. How many of you had 4 inches? So for this one, let's say the diameter of this circle is 12 inches. Once again, find the center to center distance between those circles for me. Okay, so let's start this one out. So what's this angle right here going to be? 45 degrees. That's going to be 360 divided by 8. Or 45 degrees. So now let's go ahead and we're going to cut this in half. So we get this triangle here. There's my right angle. This is 12 inches because that's my radius. What's this angle? 22.5 degrees.
6 inches, that's all.
Nice. Good job. 6 inches. So now then we're finding this side here. That's going to be the sine of 22.5 degrees equals that opposite side over 6 inches. So I'll put it over 1 and we will cross multiply and divide. Sine of 22.5 close times 6, and I'm not going to bother dividing by 1, is 2.296. Now of course we're going to double that times 2 gives us 4.59. How many of you had 4.59 inches? Good deal. Well, we've got about 6 or 7 minutes left here. In your book, on page 743, there's problems 3 through 13, the odds. And also on page 749, 1 through 17, the odds. The second set is going to be a little more difficult to find the right triangles, so be patient with yourself and just make sure you find them.